Okay, welcome back, my lovely students. So what we have now is the start of trigonometry and our look at the unit circle. So we're going to do a whole lot of work learning about the unit circle, defining the angles, all sorts of crazy stuff. So the very first thing the book starts out with is defining a whole bunch of terms. So I want you guys to actually take a sec, look in the book, type up or write up the definition for these terms. That way you've at least thought through here's the term, here's what it means. Try to put it in your own words rather than copy straight from the book. But you can copy and then describe it in your own words afterwards. But because I want you guys to think through that, I'm going to skip it. All right, so our first do some work question here says draw angles in standard position. So standard position has the initial side along the positive x-axis. And we are going to flip, rotate, whatever, not flip, but rotate angles so that the initial side is always on that positive x-axis. That's where we start when we're going to measure an angle always. So there's our XY axis. There's our initial side. And the first angle we want to sketch is 60 degrees. So what they're wanting you to think about here is how far around a full circle is this? We know a full circle is 360 degrees. So all the way around 360. So halfway around is 180. And then half of that is 90. So 60 is going to be somewhere in the first quadrant. And if we split this into thirds, 60 degrees would be roughly about there. And when you're sketching these, it's usually habitual to draw the initial side, and you draw that curvy arrow pointing to where the angle stops, and then 60 degrees. So when you're first getting used to angles, I would definitely draw that arrow. After a while, it's kind of implied since the angle's in standard position, and we labeled it with a positive number, so must go counterclockwise. But then we have our very crazy looking negative 225. Again, we'll place that initial side. And this one now, since it says negative, we're going to measure clockwise. So instead of going up and to the left, we're going to go down and to the left. So I know 225 is less than 180. So all the way over to here is 180, or negative 180 if we're going in that direction. And then it'd be negative 360 to get all the way back here. Halfway between those two is 270. And it turns out 225 is halfway between those two. So that's 90 degrees between them. Half of that is 45. 180 plus 45 is 225. So negative 225 is right here. Let me just keep that arrow. There it is. Now looking at this, to me at least, it always begs the question, okay, but why would you measure it that way when the other one is right there? And we are going to talk more about, there's an implied positive angle right there. Yes. And if we took 360, which is a whole circle, so if we basically started at the negative 225 and added 360 degrees, that'd be all the way around the circle, that would give us that purple angle, which numerically is 135. This negative 225 is also the same as positive 135 degrees. So by putting these angles in standard position, we can actually get a whole bunch of what are called coterminal angles. They're angles that have the same starting line, the same finishing line, but they're 360 degrees apart from each other. Now, the other unit that hopefully is at least vaguely familiar is what's called radians. Radians are a very odd thing because while they measure angles, degrees like is a unit of measure, like inches and centimeters. Radians actually are unitless. A radian is telling you the proportion of a full circle worth of angle measure that the angle we're talking about is. Now, in this case, it's also defined to be 1 radian, like the number 1, is the measure of a central angle of a circle that intercepts an arc equal to the length of the radius of that circle. So there's our radius, there's our angle T, this arc here that it's sweeping out. If we measured that, like cut a piece of string that length and then laid it on the radius, they'd be the same. That angle measure that meets that requirement is defined to be 1 radian. Now, looking at it, it can look like pretty close to 60, and it is, but it's not 60 degrees itself. It's a tiny bit less. So the circumference of a circle is 2 pi r. So the measure of an angle for a full circle in radians is 2 pi radians, because that is the distance around the circle if the radius is 1. So because it's a ratio of two things, and the things have the same type of unit, like a distance over a distance, there are no units. It's called dimensionless. What this means is you'll be working with something and like you'll have radians, and then in the next step, the radians like just are no longer being written in the problem. So just FYI, like that happens in physics books. It's like it's there and then now it's gone, and they just kind of like hand wave like wee and don't explain. So if we say given an angle measuring 2, and we don't put anything else, we have to assume that's 2 radians. A polite mathematician will write 2 rad or 2 radians, just so it's very clear they meant this to be radians. They're not trying to trick you and think that they made a typo and forgot the little degree bubble. I will not do that bullshit. If you're not sure what the angle measure is being measured in, ask. Because I despised it when my teachers did it in high school. So it's one of my personal vows. I will not do that. All right. So if 2 pi radians equals 360 degrees, we divide both sides by 2, then pi radians is 180 degrees. And then if we divide by the numerical value of pi, 180 divided by the 3.14159, blah, 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 comes out to about 57.3 degrees. Like I said, it's not 60. It looks like it, but it's not quite 60. And I'm saying that because we're going to find 60 degrees is a number we use a lot. Now, because this was talking about the length of the arc equal to the radius, the book decided to throw arc length, and then we're going to have angular speed in a minute and area of a sector. Like, yay. Okay. So here, arc length is defined to be, the arc length is the radius times theta. The catch here being that theta is measured in radians. So when S equals R, theta equals R over R equals 1 radian. Okay. So what you see here is they've measured out units of radians. So there's 1 radian. Then they go that same distance again, that's 2 radians. They do it again, that's 3 radians. And then these other ones down here are collinear. So they've added 180 degrees, which is pi radians. So that's why they wrote 1 plus pi, 2 plus pi, and 3 plus pi here. And we know pi is 3 and some change. So that lines up. So a little bit more than this would get us to the full 2 pi of the angle measure. All right. So what I have here are some special right triangles. So when I took geometry back in the day when dinosaurs roamed the earth, we learned about these special right triangles, and we learned that sine was a ratio of sides and cosine was a ratio of sides. The book is going to define it the way it was historically defined, which is sine and cosine are functions that take angle measures and convert it into a distance, a length, the measure of distance. But like since our unit circle, it's called a unit circle because the radius is 1 unit. So I said earlier, like we're going to see 60 degrees, like there it is. We're going to see 30 degrees a lot. We're going to see 45 degrees a lot. So knowing those two triangles, and then we do a little bit of math magic, and we get those triangles, but now the radius is equal to 1. So I can actually embed those triangles into the unit circle and get distances out of it. And we're going to see the sine and cosine specifically relate to these distances. All right, so this here is our unit circle with all the lovely degrees labeled. We can also convert those to radians. And the book has a little process for doing that. It has a proportion. If you like proportions, by all means, use the proportion. I hate this proportion with a burning passion, the way I hate most proportions, because if you're dyslexic or dysnumeric, it is so easy to mess this up and it's frustrating. What works better is dimension analysis, unit analysis. So this is asking me to convert degrees to radians, changing my units. So I just need to know what's an equivalency between degrees and radians. So we were just talking about all the way around the circle. We know is 360 degrees. That's also 2 pi radians. So since 360 degrees equals 2 pi radians, if I divide this known equivalent fact by the same amount, on the left, 360 divided by 360 is 1. Two pi divided by 360, we're just going to reduce. The 2 goes into 360 180 times. So we get pi over 180 degrees. So this creates an equivalency fraction, a fraction that we can use to change units. You guys will see this all over the place in chemistry, general chemistry. Yeah, except you guys will be doing it with moles. So here, I've got 2 things I know are equal. One thing over something that is the same size is 1. And I can always multiply by 1. So that's what I'm going to do. So we're going to take that 210 degrees And then I want degrees to go away. So I'm going to put 180 degrees down there. And I want it to be converted into radians. So I put however many radians is equal to 180 degrees, which is pi. And then I'm just going to crunch the numbers. My degrees are canceling out, they're gone. So now this is just radians, which is not even really a unit, but for what we're doing here, we're gonna keep it. So now we just have to figure out how 210 over 180 reduces, which is where your handy dandy scientific calculator can greatly help you out. After a while though, you're gonna get very, like, it's a good idea to make flashcards of the degrees to radians, or at least have some way in your head that you can do that quickly. So 21 over 18, both of those are divisible by 3. So 7 pi over 6. That is our first conversion. Same song, second verse would be 315. 315 degrees. The degrees we want to cancel on the bottom. What they are equal to on top. So we're just multiplying by a crazy form of 1 so that our units are what we want them to be. We're going to do the same thing in a little bit, going minutes and seconds or minutes and hours. All right, so 315 is a little bit uglier. So it ends up being like, I think it's divisible by 45 is what it comes out to be. Yeah, there's 4 45s and 180. And if I added one more 45 to this, it'd be 360. So 45 times 8 is 360. So this is 7 times 45. So radians are 7 pi over 4. When we put all of these on the unit circle, you can actually see some really nice patterns forming. So I don't actually normally go through this calculation. In my brain, I'm like, oh, it's one of the angles that ends in a 5. So it's a 45. And then I'm just like, and 45 is pi over 4. And then I'm just counting how many pi over 4s till I get to where 315 would be. And you can see over here, 315 is in the fourth quadrant. So there's a lot of 45s you got to count to get there. 7 of them. So I know that can be a bit of a like mind blown moment. This is by far one of the most useful and applicable things I can teach you. This will help you loads in chemistry and in physics. And it's just useful for having to do conversions. If you just realize it's always multiplying by a weird form of 1, once you learn two things are equal, you can convert between those units. And you're still welcome to use the proportion. It just drives me nuts because you have to remember what goes where. And if you put it in the wrong spot, so if you use it, I can still explain it. I'm just like, if I'm working a problem, I'm not going to do that. All right, now we're being asked to go the other way around, radians to degrees. So we've got pi over 3. Go ahead and write the radians. Now I want radians to go away, and I want it to go to degrees. I know pi radians is the same as 180 degrees. So my units cancel out. I only have degrees left, so this is going where I need it to go. And my pi's cancel. So 3 goes into 180 60 times. All right, so pi over 3 is the same as 60 degrees. So we could actually write that next to the 60 on the unit circle, like you're going to have to do for the writing assignment. Hint, hint, nudge, nudge. Now the negative 3 pi over 4. and 5 radians. So radians cancel out, going to 180 degrees. So finishing it out, 5s will cancel. 4 goes into 80, 90, 45. 3, negative 3 times 45. 90 plus 45 is 135. So negative 135 degrees. You do not have to do these calculations in your head. I do them in my head because it takes me forever to get my phone and convert it into the mode where I can do the things nicely. If you're not comfortable doing that in your head, you crunch it on the calculator. So this would be negative 3 divided by 4 times 180, enter, answer, negative 135. Cool. Your job is to know which way to type the numbers and what the units on your answer are, like what you were doing, why you were telling the calculator to crunch the numbers like that. So just because I do crap in my head does not mean y'all should do stuff in your head. I do that because I've been doing this so long. And I'm just kind of trying to show you guys the logic of how I'm getting there, why it works. I'm going to cut this video into 2 pieces because this is feeling a little long.